Okay, so this program that is showing up on the screen is a program called Mathematica, and we will be using this a little later in the semester. We'll be going to the computer lab, and you'll be doing some things with Mathematica. And so what I've got drawn here is we've got our function, okay, similar to the function we have drawn over here. And in this particular example, we are interested in an a value of 2. So we want to know the slope of our tangent line when x is equal to 2. So here I've drawn a point on our function, okay, and I've drawn a straight line that just kisses our curve, and that's our tangent line. Now, how do we create that tangent line? Well, like I was talking about over there, we really need 2 points. And so we will start with 2 separate points. Here's that fixed point. This is a comma f of a. And then over here, we've got our other x value, x comma f of x. And so the line between those 2 points, that red line, is our secant line. Now, what I want you to do as I move this animation, I want you to notice 2 things. I'd like you to notice what happens to this point right up here, as well as what is happening to the x value down here along the x-axis. So take a look at those 2 points first, and then I'm going to have you look at some other things in just a minute. So as our x value is approaching an x value of 2, that point on the curve is getting closer and closer to our fixed point. So we start far away. As x approaches a, our second point is following along the curve. So this time when I make this motion, check out what's happening to that secant line, that red secant line. As our x point gets closer to our fixed point, that secant line is getting closer and closer and closer to lining up exactly with our tangent line. Now, this can happen either from the left or the right. In the example that I drew up on the board over here, x was approaching a from the right side, but certainly when we talk about limits, we need that value, we need x to approach a both from the right and from the left. And so here I can change this animation here a little bit. And so ignore it now because we're moving away from the a value of 2. Okay, now x is approaching a from the right. Bam, tangent line, don't look. Now we're starting from the left side. X is approaching a from the left. Our secant line is getting close to our tangent line. All right, so this is dynamically what's happening when we take our limit. And so this symbol, the limit, as x approaches a, of f of x minus f of a over x minus a, that is our derivative of f at a. So we call that f prime of a. All right, so I want to stop here in chapter 2. We're going to talk more about these and how to work with this formula that we've come up with next class. But my goal for this class and the material out of chapter 2 is for you to understand, number 1, that the ratio part comes from slope of the secant line. And when we throw that limit symbol in the front, it takes a secant line and makes it into a tangent line. Okay, so